morning, students. As we have finished the chapter ray optics, and today we're going to start a fresh chapter, that is wave optics. Before going to start this chapter, I'm just giving some hints about this particular chapter, that what are we going to learn from this particular chapter. Remember that this is a very important chapter. That means from the marking point of view in the final examination, optics plays always a major role. You remember that. So in case of wave optics, what we learn in wave optics, first of all we have to know the characteristics of light, whether it is a particles or whether it is a wave. Those things we'll discuss. And after that we'll learn Huygens theory. In Huygens theory, by the help of Huygens theory, we'll try to explain different phenomena like reflection, refraction, interferences and diffractions of light. We'll discuss interferences in brief and then the diffraction. After that we'll discuss the polarization, and then finally we'll wrap up this chapter by discussing about Doppler's effect in light. Earlier you have studied about Doppler's effect of sound, so here you'll find the Doppler's effect of light as well. So in short, I have just told you how we are going to plan this particular chapter, wave optics. But before going to start those, we should know the characteristics of light. That is very important. We have got different theories about light, and different scientists at different time have given different theory about light. I mean, on the basis of the characteristics of light, different scientists has given different opinion, and some of the opinions I have tried to show you, and you'll come to know as the courses proceed or at the chapter proceed. So if we start with Newton's corpuscular theory, what does it actually means? That what was Newton's opinion, or what was Newton's theory or concept in case of the light characteristics of light? Newton told that light basically travels in the form of some particles. Okay, light travels or light is emitted by a source in the form of some particles, and these particles are known as corpuscle. That is why it is said that Newton's corpuscular theory. Understood it? Newton's corpuscular theory, what does it mean? That Newton's believed that light emitted by a source of light in the form of some particle, and those particles are known as corpuscle. But this theory had some problem later on, and this theory failed to explain some phenomenon like rectilinear, phenomenon like interferences and diffraction. Interferences, diffraction, like the major phenomena of light, was not being explained by Newton's corpuscular theory. What it explained nicely, reflection, refraction, all these phenomena was explained by Newton's corpuscular theory, but some major phenomena like interferences, diffraction, all these things, all these phenomena were not explained by Newton's corpuscular theory. That is why a scientist came, that is Huygens. I have written here clearly that light is emitted by a source in the form of particles called corpuscle. This theory was able to explain rectilinear propagation, reflection, refraction, but could not explain the phenomena like interferences and diffraction, etc. These things I have explained, and I hope you have understood it. Now, next it is Huygens. But if you compare the importance of Huygens and Newton on the time, but Newton's theory was more popular in comparison to Huygens. Am I clear? Because Newton has a lot of respect in the society and he was well known on that time in the society. And there, that's the reason. But Huygens wave theory, what Huygens wave theory was proposed and what Huygens told. Huygens told that the light does not emitted, light is not emitted by source in the form of particles. Hence, light is a type of wave. Very interesting. Light is a type of wave. That means light travels in the form of wave. Okay. So I have written clearly, light is a type of wave, but it is not only wave, it is a mechanical longitudinal wave. Again, interesting. Okay, what Huygens proposed? Huygens proposed that in this theory that the light is not of particles. Light doesn't emit it in the form of particles or corpuscular. So like that. Light is what? The light is actually mechanical longitudinal wave. That means he wanted to tell that light is a form of wave. Light is wave. Light travels in the form of wave. Okay, so here it is written that light is a type of wave. Mechanical longitudinal wave. It could explain interference differences, what was not possible by Newton's corpuscular theory earlier. Okay, so Huygens wave theory were able to explain the interferences and diffraction like major phenomena that takes place in light. But it could not explain polarization, photoelectric effect, Raman effect, etc. That means this Huygens theory was also not full-fledged. Why? Because as we found that Huygens theory was able to explain diffraction, interferences, that are fine, but unfortunately it was also not able to explain and again some major phenomena of light like polarization, okay, then your photoelectric effect, Raman effect, all these things, the major phenomena of light, those were not being able to explain by Huygens theory. Then we have to search for another new theory. Then comes Maxwell's electromagnetic theory. Maxwell electromagnetic theory somehow supported the Huygens wave theory, but it went something differently. How it went something differently? That what Maxwell proposed newly, that light is not mechanical wave. That light was mechanical, longitudinal mechanical wave. It was proposed by Huygens. But when Maxwell gave his own opinion, or Maxwell gave his own theory, what Maxwell told? That Maxwell proposed that light is not only mechanical wave but electromagnetic wave. That is also important. Light is not only mechanical wave but it is electromagnetic wave. Who told it? It was told by, or this opinion was given by Maxwell. That is why it is called Maxwell's electromagnetic theory, where he clearly told that light is not only mechanical wave, hence light is electromagnetic wave. Am I clear? You can see these things. The Huygens, what is the light is the type of wave that is mechanical longitudinal wave. And you see Maxwell's electromagnetic theory, what Maxwell told, that light is not mechanical wave but electromagnetic wave. He also believed somehow light is wave, but he added this thing that light is electromagnetic wave. Okay, once he told that light is electromagnetic wave, he told that when light propagates, that means when light propagates, when both electric field and magnetic field oscillates, that means in the oscillations of light, there are combinations of electromagnetic field and electric field and magnetic field, electromagnetic. Okay, so I have mentioned here clearly this line that light propagates according to Maxwell's electromagnetic theory when electric field and the magnetic field oscillates. Okay, these things I have told you. Light propagates as electric field and magnetic field oscillates. But biggest benefit, biggest plus point of Maxwell's electromagnetic theory was that it was a successful theory. Somehow almost all phenomena of light could be explained by this particular theory. That means reflection, refraction, interferences, diffraction, polarizations, photoelectric effect, almost all phenomena of light could be explained by the help of Maxwell's electromagnetic theory. So all phenomena could be explained by the Maxwell's electromagnetic theory. But again, there are some mistakes. There are some minus point also in Maxwell theory. Then Hertz came, a scientist came named Hertz. Hertz indirectly supported Maxwell's electromagnetic theory. Am I clear? But then when Hertz supported Maxwell's electromagnetic theory, on that time only, Einstein came. Einstein uses the Planck's quantum theory. Okay, and Einstein uses the Planck's quantum theory, and by using the Planck's quantum theory, he told that light emits some particle. Okay, light emits some energy in the form of some particles, and that is in the form of photon. And this photon, what? This is like E is equal to h nu. Each photon has an energy. That means each particle that is emitted by light, those emitted particles are in the form of photon, and this photon has each photon emitted by light particles has an energy E is equal to h nu. This is a famous formula in physics for which Einstein got the Nobel Prize. Okay, so this is Planck's quantum theory. Basically it was done by Einstein. Einstein uses Planck's quantum theory in order to give this suggestion. Here what is told, that light emits some particles and light emits energy, okay, in the form of some particle, this is photon, and each photon's particle have some energy, that is E is equal to h nu. So after having an observation of all these things, finally we come to a conclusions that whole of physics world came to a conclusion that basically light has got two nature. Okay, light may be a type of wave also, and light may be a particle also. That means light can be both particle and light maybe also wave also. That is why this is called dual nature of theory. What is dual nature theory? That light is emitted in the form of particle also, and light is emitted in the form of wave also. So this is the dual nature theory finally. That means what does dual nature theory propose? That light basically it is also emitted in the form of particles and also in the form of wave. Okay, so this is all about the concept of light, characteristics of light. We have got some idea about it, starting from Newton's corpuscular theory, Huygens wave theory, Maxwell's electromagnetic theory, Planck's quantum theory, dual nature theory. Okay, in the next class we'll go to the Huygens principle, and then we'll continue this particular chapter. But you just keep practicing all this thing hard at home so that it becomes very easy for you in the time of exams. For today, thank you so much.